Usually I don't need a microphone, I talk loud, but I'm glad this works. So thank you for waiting. I apologize for being late. Too many meetings stacked up alongside each other. So what I was asked to come and speak to you about is how simulation, specifically Autodesk simulation, fits into the message of the future of making things. I notice nobody's got the translation headsets. Is my English okay to understand? Good? Excellent. I speak all over Europe, so I'm used to speaking slowly. So I'll try to remember that as I proceed. So what I want to talk to you about is the role of simulation in the future of making things. So I've called my presentation the future of making things work, because there are all kinds of exciting technologies. And if you saw Callan Carpenter's keynote address and our keynote address from our Octo colleague, more materials, more manufacturing methods are becoming available to design shapes you would never have thought of in the traditional manufacturing world. But that puts additional challenges on us, the engineering core, to make sure that these brand new ideas, these ergonomic shapes, organic shapes, actually do the job that they're supposed to. So if you've followed the future of making things, you know that there are a couple key factors required to succeed. The industry is looking for more customization. They're looking for smarter products, and they're looking for manufacturing processes that will allow you to get your ideas, your innovations, out to market faster. To be able to customize for a market on demand requires you to rethink the way you engineer your products. And so the traditional methods of building prototypes are just no longer going to be effective because they're too slow. Doesn't mean they're not effective. The answers are good, but they're too slow to respond to market changes. It's a crime to find that you've got this great idea, but by the time you get it out to market, nobody wants it anymore. That's where simulation is going to make a big difference. So if you followed the story of the future making things, you'll know we're moving from a linear manufacturing process to a more dynamic manufacturing process where the design is regularly getting feedback from the operation in the field, so that people are making decisions about how they use a product, and those decisions get fed back into the process to redesign the product. Constantly changing our assumptions and consequently our decisions on how to move forward into the next design. This process adds even more questions to the engineering process than in the historic design process. Now we've got to think about, what is it going to do tomorrow? We got to think about, how are we going to make this? How are we going to take advantage of new materials? How are we going to address the questions and changes that keep coming up? So we're being asked to know more. And I like to say that the challenge of a design engineer is making important decisions with very little information, right? We can't always know what's going to happen to our product, how it's going to be used, what variations in manufacturing will come into play. But we have to make decisions on what we think is going to happen. We have to use our engineering intuition to make better decisions. So now that we have more questions, we need even more information to make sound decisions. And really what simulation is about is understanding the risk of not asking these questions. If you don't ask the question or you can't get an answer, you're adding more risk into the design process. And as the process moves faster and changes come more regularly, those risks start to add up over time. And that's where simulation comes into play. So the best takeaway from this presentation, when you think about where your company is going in developing products, is that the power of simulation is to make better decisions sooner. How many times have we looked at the response of a product or a failure of a machine, say, wow, I wish I'd known that was going to happen, right? Now you've got technologies, some old technologies that weren't as accessible, but you've got technologies now that are easier to use, lower cost of entry, integrated into your design platforms, be it the Inventor platform inside of the collections or inside of Fusion 360. You've got technologies embedded into the process to ask these questions as you're designing, as opposed to the traditional process, which we call the traditional validation process that I grew up with as a stress analyst and that most people are still working their way out of. The difference really comes into between what we call design analysis versus validation analysis is really differentiated by when the questions are asked. In a traditional validation process, which I would also include prototyping in, we don't necessarily ask if it's going to work, if our decision was good, until pretty far down the design process into prototyping or even manufacturing. At that point, the cost of making a change is extremely high. And the impact on our ability to turn the product around or incorporate changes coming from field information becomes almost impossible. If you're working in a validation mode, the best you're going to get out of the answers to the questions are, does it work or does it not work? Now, historically, that might have been enough. But when we're dealing with the future of dynamic, customer-driven change, waiting so long and finding out it's not going to work, or finding out it's working but not knowing if it's optimal, is no longer going to be acceptable. You need to know that the innovative changes you're making are going to work and that they're the best approach at the beginning of the process when you can make some changes. If I make it square, is that good enough? Yes. Is it the best? No. Maybe I make it circle. Is it good enough? Yes. Is it the best? Maybe not so much. Maybe it's an oval, right? You can ask those questions if you're getting answers at the design phase. You can't ask those questions in a validation mode. And that's where simulation will greatly improve your path into the future of making things. The three areas that we have identified the benefits of having an integrated product innovation platform. There are a number of benefits of this integration. The three that simulation affects the most, from what we've observed globally, is the ability to increase your innovation, to improve your product performance, and win more business. And depending on the industry you're in, some of these may be more important than the other, but they're all important parts of the growth in the future of making things a simulation can impact. So that's kind of the first setup, and hopefully you've all had the opportunity to have a discussion on the future of making things. So these terms shouldn't be, I think almost every Autodesk customer in the world has heard this several times, but hopefully it was not the first time you heard it. So what I'd like to do is share with you kind of the second half, some examples of areas we see growth in where simulation is impacting your ability to innovate, your ability to improve your product performance. That's where the optimization part comes in. Is it the best? Not just will it work, is it the best? Improving product performance, and then winning more business. And we'll talk a little bit how each of those can be impacted by these case studies. So the first one I want to share is using computational fluid dynamics in the process of architectural building construction. More and more end customers, people paying for the projects, want to make sure that the airflow is consistent. You have regular ventilation, we call it air changes per hour, that it's turned around enough so that the air doesn't get stagnant, that you can measure thermal comfort, and you've got energy efficiency. Almost every airport, I travel all over the world, almost every airport I'm in appears to overdo it, where they have huge ventilation so that there's lots of wind blowing in some parts of the terminal. Other areas you sit and you're starting to get hot, right? That's an area where they're probably wasting energy because they're trying to overcompensate for poor airflow with volume. They're just going to throw so much at it. Eventually, they're hoping the cold air gets somewhere, right? So that's wasting energy. With computational fluid dynamics, in a reasonably small amount of time, you can not only find out if you've got stagnant air, non-uniform temperature distribution, but you can also find out what's the best application of that. Quickly and easily, we've actually now developed cloud computing platforms that works with our CFD and just released this week. It's pretty exciting for us. That can solve problems like this 10 times faster than we ever could before. Throw it out to the cloud, it comes back in what was once hours, now minutes. If it used to be days, it'd be hours, which is really exciting, opening up all kinds of opportunities. Another thing to think about here, and this applies to nearly every CFD, fluid flow engineering challenges, in a test environment, how would you ever get this information? Air is invisible. So how do you know where the air is, right? If you're measuring temperatures in a room, you'll only know the temperatures where you put thermocouples. What if there's enough gradient that you've got a thermocouple here that says the temperature's good, maybe half a meter away, the temperature's bad? How do you know where to put the thermocouples? And if you're measuring velocity, is that affecting the flow? Is your test measurement changing the response that you're looking for? These are things that CFD does that testing could never do for you. You'll never get this sort of insight, even if you use smoke streams in, say, a wind tunnel or controlled environment, because you'll never get the volume to understand the insight, to really experience what it would be like to be in that room. So with this sort of technology, you can innovate new ways of controlling temperature, energy, airflow. You can improve the performance of your product, which is a building or a living space, by ensuring that the temperature is uniform, by ensuring
A lot amount of customers when you making.
If you misguess.
Yeah.
Yeah. Oh, absolutely. Absolutely. And that's a business decision you have to make.
So there's things to count.
To me, if you know what your durability requirements are and you can design to that, you win.